Moving on to chapter 2, we're going to talk about simple harmonic motion. So if you can remember with Hooke's law, the magnitude of the restoring force is proportional to the distance of displacement. So the restoring force is proportional to displacement. The question, does the magnitude of the restoring force change over time? Yes, the magnitude of the restoring force changes because displacement changes. Remember our picture of the molecule moving back and forth and back and forth, and the waveform moving out. You have periods of compression and periods of rarefaction. This is vibration or oscillation of a system. The magnitude of displacement changes over time. You go from equilibrium to maximum displacement in one direction, back to equilibrium, to maximum displacement in the other direction, and back home to equilibrium. And that is one cycle of vibration. So we have simple harmonic motion, this back and forth movement of a particle around its equilibrium. The waveform shows changes in some quantity as a function of time. So displacement, velocity, acceleration, force, momentum, all of the derived physical quantities that we discussed. A waveform is simply a graph that illustrates the nature of simple vibratory motion by plotting changes in magnitude, also known as amplitude, of displacement over time. So think of what? Waveform equals amplitude as a function of time. A waveform is just a picture. The air mass does not literally undergo an excursion of this type. Remember, the air molecule moves back and forth in the same direction of wave propagation. So a waveform, like this figure, is just a picture. The actual air mass does not travel like this. A waveform is a plot of the change in amplitude of displacement over time. So you can go from a positive amplitude of displacement to a negative amplitude of displacement over a period of time. The display is also called a time domain waveform or simply a waveform. We know that the air does not actually move like this. The waveform is simply a representation of the change in displacement of the air molecule as a function of time.